Hey guys, it's Mr. Ocean. I'm just gonna make a quick video today, kind of reviewing how do we solve a system, and I'm gonna do that by doing the last Alex assignment that I gave you, and just doing a couple problems so that you can get an example of a one solution, an example of an infinite solution, and an example of a no solution. Okay? So first, I just want to start off with kind of clearing up how do we solve a system, because I feel like maybe that's stopping us from even getting a start. So let me just bring this tool up here. So solving systems. How are we going to do that? Well, the first thing to remember is that when you have a system, that means that you're going to have two equations. Okay, that's the first thing to remember. So that's what a system stands for, is that we're going to have two equations. So what that tells us is that means that we can get two lines to appear on a graph. Now remember, whenever you have two lines on a graph, where they intersect means that is the solution. So for example, if I have one line here on Desmos and another line here on Desmos, right here where they cross would be my answer. Okay? But there's a few details with that part. First thing to know is that we need to be in slope-intercept form, which is y equals mx plus b, so that we can actually use Desmos to help us get this picture in the first place. Okay? So that's going to be one thing we have to keep in mind. And the second thing to keep in mind is the types of solutions. So what do I mean by that? Well, I mean those infinite solutions and no solutions I was talking about. So remember, we have three main types of solutions. We talked about this a long time ago. So if you don't remember, that's okay. That's why I'm making this little intro part to the video as a reminder. Okay? So, if you have what we call let's see, I'll do like yellow here, a one solution or a unique solution, what that means is you have two lines that cross only one time. So you see right here, the two lines only cross at this one point, therefore it's a one solution or a unique solution. If you got something that represents a no solution, so we'll just put no SOL for no solution, that means that you have two lines that never intersect. So if you put your two equations in Desmos and you search and they never touch, well, since they have no intersection, then they have no solution. And then lastly, we have infinite solution. Sometimes this is called all real numbers, because if you have all the numbers, well then you have, infinite answers. And what this looks like is, if you put your lines in Desmos, maybe the first one looks like this, and when you put the second one on, it looks the exact same. Well, there, technically you're intersecting here and here and here and here and here and here and here infinite times, right? So if they're the same line, or in other words, they kind of overlap, right? They're on top of one another. Well, that means that they technically touch each other infinite times, right? They intersect infinite times, so you get infinite solution. All right, so this is our game plan. If we're solving a system, we know we're going to get two lines on a graph. Where those lines cross is our solution, and we just talked about the different types of pictures we can get, okay? To get these pictures, we're going to use Desmos, but the key thing about Desmos is it can only use slope-intercept form, okay? So this is going to be the main thing that makes the problems difficult, is that we have to convert. So I'm going to do a few problems real fast, try to help you guys out one last time. I'm probably going to be gone for a week or two, so I really need you guys to, like, you know, if you have questions, reach out. I'll try my best to help, but just keep reviewing these, ask for help in class so that we can get them done, all right? So I'll leave that there. If you guys want to, like, take a screenshot of that part so you kind of have, like, something to look at. I know it ain't pretty, but I'm trying my best. Look at this. So, to do some problems really fast, just to show you the thought process, I have this problem from your types of solutions assignment. It's the last one on Alex that I gave to you guys. We have system A and system B. First, I'm just going to work system A, okay? So for system A, I'm going to have this top line be blue and this bottom line be red, just so that you know which one I'm working with. And the first thing I notice with both of these is that if I want to put them in Desmos, I'm going to have to convert this top one because it's not in slope-intercept form, right? I know that because y isn't by itself on this side of the equal sign. I have to deal with the 6x, and I have to deal with this minus sign right here. So I need to figure all that out and convert. Same thing with the bottom one. Y is not by itself either, so I'm going to have to convert both of these. So this is like the real part of the problem that you actually have to solve. So let's keep it blue. 6x minus y equals negative 5. So let's bring that over here so I have some room. So we have 6, it's ugly, 6x minus y equals 5. Okay, so to convert, quick reminder on how to convert. First thing you're going to do is you're going to remove all of the x's from that side. So I want y by itself, so I definitely have to get rid of 6x. How do I do that? I say minus 6x on both sides. Okay? So these cancel out, and I'm left with negative y. Don't forget the symbol in front of y, even if it has no number. It still says minus y, and that's important that we don't forget that. Then I just copy the other side, so it said 5 minus 6x, so I write the same thing. Maybe I can make that look a little nicer. There we go. Then we move on to step 2. Step 2 says that we need to divide. Now this is going to be a little weird for this example because we don't have a number in front of y, but remember, if they never put a number in front of y, technically it's a invisible 1. Okay? So here we're going to divide away whatever is in front of y, and that is a negative 1 in this scenario. So I say divide by negative 1. Divide by negative 1 on both sides. And I'm going to go ahead and remind you guys that if you're ever dividing a whole side, that means everything gets divided. So I'm going to write this as 2 separate divides real fast, so my next step is easier. Okay, so there we go there. Then we simplify, so the negative 1's cancel out here, leaving me with just y. 5 over negative 1 is negative 5, and then be careful here, because I have negative 6x divided by negative 1. So 2 negatives makes that positive. 6 over 1 gives me 6. Remember, if you ever have trouble simplifying, just make sure that you try it in Desmos and type the same signs. So just don't forget that this 6 is negative and it's divided by negative 1. Okay? And all I did there for step number 3 is I simplify. Okay, simplify. So just be very careful with your signs. Let Desmos help you. When I say let Desmos help you, I'm not saying type in everything. I'm just saying, like, if I don't know what 5 divided by negative 1 is, well, I ask Desmos, hey, what is the answer to this? Oh, it tells me negative 5, so I can write that down for later. Okay? Desmos isn't going to just solve the whole thing for you. But if you wanted to check, like, one fraction at a time, it can give you that. So take advantage of that. Okay. So now, this equation is Desmos ready. So I'm going to move on to that second equation now before we start typing stuff in. And that was negative 6x plus y equals 5. So negative 6x plus y equals 5. Okay, so same process here. We said get rid of that. We said step 1 was remove the x's. So here I have minus 6x. So the opposite to minusing is we add plus 6x on both sides. Might run out of room here, so I'll try to be careful. So they end up canceling out. Yeah, they cancel out. So I get left over with the y. This one's positive, so I can just write regular y. I don't have to bring that along. And then I just copy their side, 5 plus 6x. And the best part about this is, I'm done. Right? This was actually a pretty easy one, because y is already by itself, and there's nothing to simplify. So this one's already good to go. My top one's good to go. So all I do now is I send them to Desmos, and I see what solution do we have. And you know what? I'm glad I double checked, because if you notice in my blue equation, I actually wrote positive 5 for that whole problem, and it says negative 5. So I'm glad I double checked that before I left, which is not a terrible change. I can fix that real fast, so I'm sorry about that. I'm just going to add my negative 5 there, negative 5 there. And now, as I said earlier, negative 5 over negative 1, that's 2 negatives. So this actually becomes positive 5. Okay, so I'm glad I double checked that. Everything else seems fine. So here, let's see if I can, I'm going to take these two equations. They actually are the same equation, right? So that makes it easier to memorize. So y equals 5 plus 6x. I'm going to take that to Desmos. So I go over to Desmos. And I say, well, my first equation was y equals 5 plus 6x. And my second equation was also y equals 5 plus 6x. If it would type it, 6x. There we go. There we go. And now, would you look at that? My red and blue line are the exact same line, which, you know, you guys probably already figured out when you saw that they were the same equation. So, that means that for this answer here, we would say that these are an infinite solution. Okay, this system has infinitely many solutions because they are the same line as we see here. Technically, they are intersecting on all these. Okay? All right, so let's now try this part B, or the system B, real fast. Okay, I know this is a longer video, I apologize, but I just want to make sure I give you plenty of examples. So system A, we said these were technically the exact same line, so we get infinitely many solutions. Let's now try system B. Same thing, I'm going to check my equations, and I see, oh, the first one, I'm going to have to convert, and I'm going to make it blue again. So it's easy to follow. How do I know that? Well, the y isn't by itself, right? So I'm going to have to move some pieces around. Bottom equation, same thing. I'm going to have to convert because there's a lot of things bothering y. So we'll do that again. So let's bring the blue equation over. X plus 3y equals 13. So we have x plus 3y equals 13. Remember, we want to get y by itself. First step is remove x. So we're going to say minus x on both sides, because the opposite to positive x is a negative x. They cancel. And we get 3y equals 13 minus x. Next step is to divide. So we're going to divide both sides by 3. Again, I'm going to go ahead and already separate the fractions just so it's easier. My 3's cancel there, and I'm left with y equals 13 over 3. I don't think that simplifies, but we could double check in Desmos. And minus x over 3. This should be ready for Desmos, so we'll hold on to that for later. And we're going to go to our second equation. Okay? All we're doing is converting. So this next equation, let's see, negative x plus 3y equals 5. Okay? Negative x plus 3y equals 5. All right. So same thing. I want y by itself. I'm going to use the same steps as before. Step number 1, remove x. So how do I get rid of a minus x? Well, we do the opposite and we add x to both sides. So they cancel out. That leaves me with 3y equals, I just copy the other side, 5 plus x. And then we divide away the number in front of y. So divide by 3. Go ahead and separate already just so that it's easier to simplify if we have anything to simplify. These 3's cancel. And I'm going to write my answer over here actually so I don't run out of room. We have y is the only thing left over, which is good because we want it by itself, is equal to 5 over 3, which I don't think simplifies, but remember, you can always double check in Desmos if you're not sure, plus x over 3, and now that should be ready for Desmos. Okay, so notice that our equations don't look the same this time, so you're probably thinking that it's not infinite, right? Infinite is when they're the exact same line in Desmos. Since they don't look the same here, chances are it's not that one. So what we're going to check now is, okay, is it one solution or do they never cross at all? Easiest way to find that out is with our handy dandy Desmos. So I'm going to put both of these in. 13 over 3 minus x over 3. So get rid of these. Y equals 13 divided by 3. 13 divided by 3. I believe I said minus x divided by 3. Okay. Yeah, 13 over 3 minus, okay. Then we do our red equation, 5 over 3 plus x over 3. So over here, y equals 5 over 3. I believe we said plus x divided by 3. And when you look at that, we get only one cross at 4, 3. And remember, a solution to a system does want the x and y value. Okay? So we want 4, 3. So if we go back to over here, we can say that this has one solution, sometimes called just a unique solution. We would select this one, and we would say our answer is 4, 3. That's the coordinate point where it crosses. Okay? Alright, so that was a good example of what an infinite solution looks like. Right? We converted, found out they're the same, they're infinite. That was a good example of what a unique looks like. We converted them, and they happen to be only crossing one time. So let's see if we can get one more example where we can see something that is a no solution. And oh, would you look at that, I just happen to have a screenshot of a problem that might have a no solution. That's crazy. Who would have known? Alright, so I'm going to skip part A because, newsflash, that's not the no solution, and this video is already really long. So let's go to part B. Part B is great because if you look at the equations, the top equation has y by itself, so it's ready for Desmos. And the bottom equation has y by itself, so it's also ready for Desmos. Okay? Now, anytime you notice this, it could still be any of the answers over here. Okay, I want to make that clear. I could still be no solution, or unique, or infinite. Okay? So if it's like easy to type in, that doesn't mean it's going to be, you know, no one type. Like it can be any of them, is what I'm trying to say. Right? So I still don't know which one it is, but what you do get when they're set up perfectly like this is you don't have to convert. So there's no converting here, which means that you don't really have to do any work. You just go straight to Desmos at the start, and then you see what answer you get because you put it in Desmos. Okay, so hopefully that made sense. Basically, this just means it's a super easy problem, right? There's nothing to do except look at what the picture is on Desmos and then take that as our answer. Okay, so that's what I'm going to do. 4x plus 8, 4x plus 5. So if I go back to my Desmos calculator, y equals 4x plus 8, y equals 4x plus 5. I'm pretty sure that's what it was. Plus 8 plus 5. Yeah, okay, cool. And at first glance, it looks pretty parallel. I'll try to zoom out a little bit so I can see more. And yeah, it looks like they're never going to touch. It doesn't look like they're getting any closer. They look the same distance no matter where I go. If I go the other direction, scroll, scroll, scroll. Yeah, nothing, right? So, if they never cross, right, then I have no solution because they have no intersect. And that's it. Okay? So that's an example of each type of the solutions that you could potentially see. So once you learn what each picture kind of looks like, right, if they have no intersect, or do they intersect only one time, or do they look like the exact same line, so it just kind of looks like one line only because they're the same thing, as long as you know what each of these goes to, like this goes to one solution, if they look the same it goes to infinite, then the only thing that you really have to do is sometimes convert, right? This last problem, it's already set up for you, so you just have to go to Desmos and know what to look for. If I were to do system A at the top, that one I would have to convert, right? Because the y's aren't by itself. So if you can get really comfortable with the converting part, all it is after that is just making sure you don't mistype anything in Desmos and learn how to read the pictures. So I know this was a long one, but hopefully something about it makes it easier for you. And the good news about this video is that if you can get through this video and it makes sense to you, all of the other solving systems ALEKS assignments you can do, because this is the hardest one by far. Okay, the one before this ALEKS assignment that I gave you guys just introduced converting, but all of them had only a unique solution. The one before that was just straight up, can you type things into Desmos and tell me where they cross? Okay, so if you can do this, then you are good to go. The other assignment should be easy. So hopefully this helps. If not, let me know. And sorry for the long video, but I wanted to try to give you guys something to look at if it could help. All right, so good luck. Send me questions. I'll see what I can do through a video. All right, have a good day, guys.